This is Kelly Hill, technology reporter for RCR Wireless News. I'm here today with Nandish Chalisazar, who is Director and Head of Engineering for the Analytics Business Unit at Azimuth Systems. Welcome, Nandish.
Thanks, Kelly. Glad to be here.
Great. Now, I'm wondering if we can start off with you telling us a little bit about what it is and what it is you do, your area of focus, and then we'll jump into some questions about, focusing on device network interactions and some of the testing surrounding that, as well as some of the new, how that works with some of the new network technologies. So, so tell us about your approach and what it is you do.
Absolutely. So, hi everybody. I'm Nandish Chalisazar at Azimuth Systems. I'm Director and Head of Engineering of the Analytics Business Unit. My main responsibility is to build new and innovative products for device network analytics. There are a lot of analytics companies out there, but as far as benchmarking and regression testing goes, whether you're comparing operators or devices or networks, I think there's a big need out there to understand the why and what of what's going on with different operators and different devices and networks in terms of if we see a difference in performance, what really is going on that's contributing to that performance difference. I think there's a lot of tools out there which tell you that this operator is better than the other operating better than the other device. But why is that really happening is really the main focus of my team over here. What we want to do is try and build an innovative products that solve the question of why is something happening when it happens. And obviously with device network analytics, there's so much going on between the device and the network at different layers of the protocol stack. It's really important to quickly and easily understand which is the focus area that will help you understand the answer to your problem essentially. And so we're building tools from automation and analysis perspective to really help feed into the need for the industry to quickly and more easily resolve complex issues between the device and the network. To first isolate the issues. Even isolation of issues is a very big problem today. So my team is responsible for helping to identify what are the main areas that are contributing to the problem and help customers resolve issues with the right analytics as quickly as you can, kind of thing.
Okay, great. Now, one of the complicated things going on in networks right now is voice over LTE or VoLTE. We're starting to see both devices that are capable of VoLTE, the iPhone 6, for example, and we're also seeing commercial rollouts. I think for the first time, and this has been a long time coming. So, how would you describe the state of the VoLTE ecosystem right now? And and maybe we can talk a little bit about what are some of the complications in terms of device network interactions when it comes to VoLTE.
Sure. So I think VoLTE ecosystem has got off to a good start. I would say. I think after some delays in deployments and stuff like that, I think it's finally off the ground, which is good news. I think the device vendors, the RAN vendors, the EPC vendors, the IMS vendors have all come together and kind of solved some of the complex challenges in getting VoLTE deployed, at least from a deployment perspective, to get it to work, quote unquote, to work. I think they've done a good job of coming together and getting VoLTE to work. But I think that's where it's still at a very nascent stage where it works, but does it work really well? Does it work to the expectations of the end users? Because VoLTE has a big challenge or a big expectation to fill because we're all used to making voice calls on 3G networks, and over the many years we've kind of now gotten to a point where we don't expect too many drop calls or too many connection failures to the network, and the voice quality has to be fairly good when we talk essentially. VoLTE, even though it's a very new and complex technology, it pretty much the expectation is to match the circuit switch voice performance that we are all very used to. And so I think the ecosystem has got off to a good start to kind of at least get it to work initially, but there are a lot of challenges remaining in terms of interoperability across networks. Today you cannot really make VoLTE calls between one operator and another operator. Even from an individual operator's perspective, the protocol stacks or the VoLTE clients on each of these devices from each of the OEM vendors may be very different. So there may be interoperability issues that you have to work through to kind of really get VoLTE up and running in a more timely fashion. Because I think getting VoLTE to work is one thing, but there's a lot of time pressure to get it deployed as quickly as you can. Everybody wants to deploy very quickly, and in that case, the interoperability is a big problem today. Getting it to work across operator networks is a big problem. Getting to roam on different operator networks is a big problem today. So I think we've got a good foundation, but we have a long way to go in terms of making it work as we are working on the 3G network today. There are a lot of expectations from the 3G network. We've got the initial things to work on VoLTE today, but I think there's a lot more to do to kind of make it interoperable and seamless across all scenarios.
Yeah, and we've also I think we've heard from AT&T and Verizon already that that working on interoperability is one of their one of their priorities. So do you think that interoperability is kind of the next big step for VoLTE, or do you think it's more important that we see wider deployments first?
Right. So I think we need to get the VoLTE performance underway as well. So I think even from what they've deployed, they need to make sure that the VoLTE performance that the end user is going to experience is fairly good with what they've deployed. But in parallel, they've got to start working to kind of expand the scope of VoLTE to across operators. So I think it has to go hand in hand. But in terms of prioritization, I think each operator, my feeling is it would want to prioritize the performance of VoLTE, and then in parallel work with getting the interoperability going across operator networks. Because I think with VoLTE, I think there's still drop calls and other stuff that still need to be resolved. As I said, functionally it seems to be working, but with so many challenges across so many different carriers that the operators are deploying, multi-band deployments, mobility deployments, IRAT deployments. They really need to kind of get that under control and make sure that coverage gaps that they have on LTE does not lead to VoLTE call drops and stuff like that. So I think optimization of VoLTE is going to be the key step now. And then in parallel with that, they're going to kind of start working towards interoperability, because that's also a very important step. Like SKT has had 3 different operators that have deployed VoLTE for many years, and still they don't work between different operators. That's a big challenge to solve. But I think my guess is that SKT is first trying to solve the VoLTE performance problems first, kind of get it more stable and get the end consumers happy about VoLTE, because I think that's going to be a next bit. That's a big launching pad for new services that the operators want to launch. With RCS coming in, that's really going to be the next big thing with video over LTE and RCS. If VoLTE doesn't work very well, then there's no concept of RCS or video over LTE, because those are going to be even more complicated on top of VoLTE. So I think they need to get a really good foundation which works very well, and then add these other services on top of it while they're trying to get the operator compliance going at the same time, essentially. So a lot to do, but my guess is they would go in steps of optimization first, make it better, and then add more services and more interoperability features as time moves along.
Okay, great. Let's talk for a minute about Azimuth's testing approach and your focus on device network interactions. When customers use your solutions, what pain points are they trying to address? Is this happening in the R&D phase, during troubleshooting? Give us kind of a sense of when the solution, when people are looking at device network interactions and, and what they're trying to solve.
Sure, absolutely. So I think most of our customers, are kind of looking at our solutions for pre-launch, at least at this point in time. You can really use it for multiple different purposes, but really before you launch new technology, before you launch new devices, those are the times when you're really worried about making sure there's no customer impact when you launch. And what customers are trying to do is use our solutions for automating, making voice calls, or automating or making FTP downloads and stuff like that when they're deploying new technologies with VoLTE and LTE data performance. And really kind of benchmark performance across a golden reference device, or benchmark their operator performance against another operator's performance, and so on. So before they launch a new technology or a new device, they really want to make sure that they've looked at things holistically before they get put in the hands of the consumer. Because I think our industry has been fairly siloed in many ways. Folks look at throughput or data speeds, folks look at call drop rates, but really, when you get a particular throughput, even the throughput is very good. Is that throughput coming at the cost of high signaling? Is that throughput coming at the cost of high battery life? Is that all those things need to be considered before you launch the device? And I think our solutions are kind of being used by the operators or by the customers to really kind of look at things at all different layers and not just focus on one silo of the end-to-end performance before you launch the device, so that you're confident that when you launch, there are 2 important things, right? Performance and capacity in the network. You need to make sure that the end user is happy and he gets the right performance, and he gets really good user experience. But at the same time, that you don't want to break the network through more signaling or more data usage and stuff like that. I think device network interaction is all about looking at things holistically across all the different layers of the protocol stack. And I think our solution is designed to kind of cater to that, where we don't want operators to kind of only focus on throughput or data speed just because that's really the big marketing term out there. We really want operators to be happy where the investment that they're making in the new network leads to better experience for the end consumer, but it comes at the lowest cost to the network, basically. And that's only be possible by looking at the different layers of the protocol stack and looking at the right KPIs on all the layers of the protocol stack, to then guarantee a good user experience and a good network capacity usage, essentially.
Okay. So when you're talking about device network interactions, obviously we have very complicated devices now that are operating in multiple technologies, very, very capable devices, and we also have networks that have a high degree of complexity as well. So when you're looking at device network interactions, can you talk a little bit about isolating, which is which? Is it a device issue? Is it a network issue? And I'm wondering if you can, tell us any, any stories of lessons learned that were, interesting or, unusual.
Absolutely. I think that's a very interesting question. As you said, device network interaction, I would, if I were to give an analogy, that's like looking for a needle in two haystacks. Needle in a haystack itself is very difficult, but looking for one needle in two haystacks is even more difficult. And I would say that these two haystacks are the two protocol stacks of the device side and the network side, essentially. And it's an extremely complicated thing where any time that you look for an issue, there's always a blame game going on between the device and the network guys, because there are different teams that are looking at this. And each operator, even though they may find a problem, they may point it to an OEM problem or a network problem or network infrastructure problem. So there's so many different layers or so many different guys involved in this whole process that it's very hard to isolate where it is going, where's the problem really lying over here. I think I can give you some examples where device network analysis has really helped to kind of catch the right issue at the right point in time before it kind of becomes a big problem for the end consumer or for the operator. Maybe I'll point to 2 or 3 examples today to just kind of give you a sense of how device network analysis has helped operators and customers to really solve real world issues. So one of the examples, a flagship device was about to be launched in a tier 1 operator's network, and they were doing user experience testing like doing YouTube downloads. They wanted to kind of just make sure that you do YouTube downloads and the throughput and user experience is fairly good. And what they found is they had a reference device and this new flagship device that was about to be launched. And the user experience in terms of YouTube data speeds, in terms of YouTube stoppages and start overs, they look very comparable. The throughput speeds, if I remember correctly, was about 6 megabits per second on the reference device as well as the new device that was about to be launched. So typically when you look at this, you would say, yeah, this is pretty good. It looks like YouTube performance is comparable to that golden device that the operator has. It's ready for launch. But then when they use a solution for device network analysis, they found that when you look at other KPIs in terms of signaling, for example, we found that when that YouTube download was being done on a flagship device, it was actually making 3 times as many more connections for completing the YouTube download compared to the reference device. So really, if it's a flagship device and if there are millions of these devices going to be launched, if each of these devices is going to cause more signaling, that's going to lead to a signaling storm in the network, and it could bring down the network, or it could lead to more provisioning for the network, which means you need to add more capacity to the network. So it's bad for the operators and the end consumer in some way, because all those costs contribute to the end consumer in some way. So I think looking at this holistic device network interaction, where you look at every layer of the protocol stack in terms of signaling, in terms of battery usage, in terms of throughput, in terms of connection performance, all of that is very critical, and that's what a solution helps us kind of look at. Be confident that this device or network technology is going to work as expected from a user. Another example that I would point out is related to voltage. So with voltage, there was an example where there's a voltage call drop when our operators were doing some drive testing with voltage, and call drop is a very bad thing. It's like one of the worst things that you can experience while you're talking on the phone. And when they found this voltage call drop, a typical approach to solving a voltage call drop is first you look at the RF. How is the RF really looking like? Like how is the wireless link really looking like? And when the customer looked at this, they said the RF looked pretty good. It was like very high signal to noise ratios. The coverage looked very good. So then the immediate reaction from most people is, oh, so the wireless link, which is the kind of the most like challenging link in the network, if that looks good, then this must be some kind of network issue where the network may not have done something between the core network or between the node Bs that could have led to the call drop. And so immediately then you kind of get lost saying, okay, how did you even come to a conclusion of this being a network issue just because the wireless link was good enough, basically, right? That's the typical approach today, because RF engineers are very good at looking at RF performance issues. Network engineers are very good at looking at network issues, essentially. But then when we started looking at the device network analysis of this whole issue, within 10 minutes it became pretty obvious that this was actually a device issue. What we found was that even in very good RF conditions, the packets were coming at the physical layer to the UE. When you look at really how packets are flowing between the device, between the UE and the network, obviously these packets are being packaged at the physical layer, and then there are headers at the upper layers, essentially the MAC layer, the RLC layer, the IP layer, and so on. And what our device network analysis solution does is it tells you what's going on at each of these different layers. And so when we started peeling the onion, what we saw was the packets, the VoLTE packets were coming in fine at the physical layer, which kind of justifies that the RF conditions are very good. The eNode B was sending those packets fine, and the UE was receiving all of those physical layer packets fine. But what we saw was all those physical layer packets are not making it to the IP layer. And so that's really a wide-ranging issue where most people would have said this is a network issue and just kind of left it alone, saying that this is a one-off network issue, let's not worry about it because it's not happening all the time. But really what we found was a device issue, and I think that's where device network analysis helps to isolate whether this is a device issue or a network issue first. And then when you start looking at the different layers of the protocol stack, from the physical layer, MAC layer, up to the higher layers, it then tells you that this is the layer where the problem is really existing, and you've got to go solve this problem. And that's what really this analysis or device network interaction helps to kind of solve these problems in a very quick fashion, because most of the times isolating the issue is really 80% of the work done. Really, once you've isolated to a specific area, then you can really go and you get all the right experts in and you can solve it very quickly. And by looking at all these different layers and kind of understanding which is the layer that's causing this problem and whether it's on the device and the network, that level of isolation is kind of huge for the industry essentially. I think throughput issues, drop call issues take like weeks to really solve. By having the right device network solution, you can really make this in the order of hours or minutes rather than having to spend days and weeks kind of thing essentially. So I think that's where looking for the needle in two haystacks becomes easier as long as you understand what's happening at the different layers. And I think the tools that are there in the industry don't solve that very well. The tools really rely on expertise from an engineer's perspective to really go and think about saying, should I go look at the network side? Should I go look at the device side? And depending on what your comfort level is, you may look at the physical layer because you're really very comfortable at the physical layer, or you may look at the IP layer because they're experts at the IP layer. But what we need as an industry is to get the whole view in one place essentially. And I think that's what our solution tries to address, where we give a report which tells you what's happening at each layer. And once you have that, the peeled onion in front of you, when peeling an onion is very, very hard, right? But if the onion is already peeled, then you know what part of the onion is bad, and then you can kind of peel it off and really solve the problem for you.
Okay. Now, I want to ask about Azimuth's RNX network emulator. I know that's now you're focused on device network analytics, but I did want to ask kind of in general, as we approach some of the features that are happening for LTE advanced small cells, HETnets, carrier aggregation, moving forward with MIMO, beamforming, what features of LTE advanced do you see as getting the most interest right now, and I'm wondering if you can address some of the challenges that are there. Obviously some of these things are extremely complicated, both on the network side and on the device side.
That's a very good question, Kelly. So I think when we start building the Azimuth RNX channel emulator, really we try to look at what's coming up in the industry, what are the major pain points in the industry, and one of the major pain points was there were so many different radio links that people had to kind of test with. With carrier aggregation, there are multiple eNode Bs involved on just one place, and then when you need to do mobility, you have multiple eNode Bs. And there are so many radio links that are getting involved that when the lab guys or the lab engineers are trying to test new technologies and validate them, they didn't really have a scalable, foolproof solution to kind of consider these advanced technologies that were coming in essentially. And so the RNX channel emulator box was really designed with that in mind to try and solve and make it future-proof in terms of trying to emulate multiple radio links. These multiple radio links could be coming through carrier aggregation technology, through HETnets and small cells, through IC kind of deployments, and so on. So I think the real key word is multiple radio links need to be tested at the same time to really make sure that the technology works from mobility perspective, from a handover, from a functional perspective, and so on. So the RNX channel emulator really solves the complex network problem where lab engineers were used to testing a couple of base stations or a couple of frequencies, and that was fine for the older technologies, but with new technologies with so many different radio links, they needed a scalable, foolproof box or future-proof box that can really kind of test carrier aggregation, HETnet, beamforming, all these different things that you just mentioned, multi-user MIMO, and so on, in a very easy and friendly, user-friendly fashion. So what we've done is not only built the box, but we've built the automation and smarts on top of it to make the process of testing very, very easy, because the technology itself is already complex. But then if the testing again has to be very complex, then this would mean that for doing so many different test cases, it's going to take forever to really launch the technology or the device. So we've added the software smarts on top of this hardware to really kind of make it very easy to configure scenarios. People really want to kind of work out of use case scenarios in the field, saying that when I have one user over here and another user over here, and then there are 3 base stations around them, how do I test mobility between these base stations? How do I test throughput experience when the user is moving from one base station to another base station? So the RNX works on all that particular scheduling problem by giving us customers very high capacity for testing networks and testing new technologies like carrier aggregation and beamforming.
Okay, great. So one question I want to ask, just kind of a general thing. I think we're starting to see the use of more analytics in network testing, and I'm wondering, you as someone who focuses on analytics and device network interactions, what role do you see analytics playing in network testing, and how do you see that evolving?
Sure, that's a very good question. I think, to me, honestly, I feel that once the network is deployed, analytics is the single most important thing. Because without analytics, it's like driving a car blindfolded. The car works, but you really don't know what's going on unless you focus on what you're seeing, essentially. And analytics will play a very important role in multiple areas. One is from a performance perspective, right? Analytics is really important to understand what is the end user experience when you've deployed this new technology from VoLTE or carrier aggregation or anything that's coming down the road. It's really going to help to understand and level set the expectation of what the consumer's experience is at any given point in time, and is he really getting the benefit of what you've deployed, essentially. At the same time, analytics is going to be very critical to make sure that you're getting the ROI out of the investments that you've made. From a capacity perspective, operators are buying spectrum to really kind of keep up with the capacity needs of the consumer. Everybody wants more data usage, and as you saw from the FCC auctions recently, $35 billion for the latest auction. Things are getting more and more expensive for operators because they need to keep up with the data demands of the end consumer, and everybody wants it at a cheap price. And so I think analytics is going to really help to kind of make sure that the performance is delivered, but with also the right investments. You don't want to over provision or under provision the network. You want to really look at the capacity of your network and make sure that you are kind of provisioning for the future, but not over provisioning in many ways, essentially, right? So I think analytics is going to be critical for ultimately getting the ROI out of the investments that everybody is making, essentially. And that analytics is going to be critical to make sure that the end user experience is delivered at the lowest possible cost, so that the end user and the operator and the ecosystem around it benefits out of the technologies that are being deployed. And even from a data monetization perspective, analytics is going to play a very big role to really understand what is the end user really doing, what does he like, what does he not like, what are the areas that he's willing to pay for. For example, with VoLTE, as I was mentioning earlier, the operators are challenged big time today in terms of ARPU. Like the average revenue per user has kind of pretty much got stuck for many years now for the operators, and they're really trying to figure out how to improve the ARPU for them and kind of really benefit from all the investment they are making. And so with VoLTE, I think that's one of the next big chances to kind of help improve the ARPU for them. With deploying RCS and value-added differentiation, where customers would be able to kind of chat through the address book directly. Customers would be able to kind of send files just directly through the address book. And there are so many different features of RCS that are very appealing to the end consumer, video over LTE. But all of these technologies are going to be deployed, like video over LTE, for example, is going to place a tremendous amount of strain on the operator's network, essentially, because there was a statistic which said, each video over LTE call could lead to 6 to 8 MB of data usage, essentially, which is way different from a VoLTE call. So I think, considering all of that, the new technologies and the new things that are going to get deployed provides a big opportunity to improve the ARPU and improve the end user experience. But I think the analytics has to kick in to really make sure that you're offering all of this at the right price and kind of getting the return on your investments and delivering the right performance for the end consumer.
Okay. Great. Well, I've been talking with Nandish excuse me, I'm going to get this right. Chilasazar, who is Director and Head of Engineering for the Analytics Business Unit at Azimuth Systems. Nandish, thank you so much for your time today. I really appreciate it.
Thanks, Kelly. Thank you very much. Happy Thanksgiving.